Welcome to chemistry basic videos. Today we'll be doing aldol condensation. Name reaction. Now aldol condensation, what it is? It is a reaction between a compound having an alpha hydrogen atom which in presence of a base will form an enolate ion, and another compound having a carbonyl group. In presence of a base, they give you an addition product called as aldol because it has got an hydroxy group, OL group, and an aldehydic group, so it is called as aldol. Or this is alpha carbon atom to the carbonyl group, this is beta, so it is also called as beta hydroxyaldehyde. So basically aldol is an addition reaction. It is not a condensation in the first step. Now because there is OH group and H atom in the neighboring carbon atom, base already is present, dehydration takes place. This H, one H from here, and the OH loses a molecule of water and we have got a double bond. Now this is the second step and the compound will be called as, this is a ketonic group, alpha beta unsaturated aldehyde, and if this was R, this would have been called as alpha beta unsaturated ketone. So this is aldol condensation. Now see the mechanism. Base is present, so it will abstract a proton, correct? Because this proton H plus is lost, we'll have two electrons over here and the bond will shift over here. This electrons will shift over here and we'll get an enolate ion. So three things. Base abstracts the proton, takes away, this bond shifts over here, and then this bond shifts on the oxygen and we get an enolate ion. So resulting, what we'll have is this compound, this ion, this, and yes, this is an enolate ion. This enolate ion acts as the nucleophile and the other carbonyl group compound will act as the electrophile. This bond will shift over here, negative charge, and this bond will attack over here and join it. So in aldol condensation also there is the formation of C-C bond. So see this bond, if I remove it, will have from here to here. This, now wait just a minute, this is CO. It needs one hydrogen from where? The one which have been extracted over here, and we get over here as H. This is your aldol. A CC bond is formed. I'll explain to you separately, but let me tell you first here. CC bond is formed and OH comes over here. This changes into CO. Aldol is formed. Now this next step was dehydration. Again the base takes away one hydrogen atom, H plus ion, sorry, and then the bond shifts over here, correct? They will get a double bond. This is kicked out, from where they'll get H. The base has recently taken this hydrogen atom, so they form minus H2O and we will have a C double bond over here. This is lost. Alpha beta unsaturated. Now only this is R over here. This is R, sorry, this is R already, this thing. Alpha beta unsaturated aldehyde. I'll explain to you separately the mechanism. Now I have explained to you the mechanism. Again I'll explain. See here, this is our compound which is going to form the enolate. The base I have taken as alkoxide ion OCH3. Step 1, abstracts the proton, bond shifts over there, forms the enolate ion. Then the carbonyl group is there, this will act as the nucleophile, this will act as the electrophile. This bond will form a CC bond Again there will be formation of the enolate ion, and this will turn back making carbon tetravalent CO. Now we have got an enolate ion. How to add H over here? So we know in the base H is there because they have extracted in the first step. So that H goes over here and it forms an aldol beta hydroxyaldehyde. The reaction basically is over, but then next step is dehydration. Dehydration, we know the base will abstract one proton, the single bond will shift and form a double bond, and then the OH will be expelled. It will take that proton which the base has already taken and form a water molecule. See here in this reaction, again the base is fresh over here, it takes away this proton, this bond shifts over here, OH is expelled. Why? It is because it wants to form water molecule of the H over here. So base catalyzed dehydration. This was step 1 and this was step 2. Step 2. Step 1 is formation of aldol and step 2 is dehydration of the aldol to alpha beta unsaturated aldehyde or ketone. That's okay. Now we are doing what is mixed aldol condensation. It is also called as cross aldol condensation. Mixed will give you the idea that one of the compound will have an alpha hydrogen atom, but the other will not, which will be either aldehyde or a ketone. Now see, this is para nitrobenzaldehyde. It doesn't have any alpha hydrogen atom. Now this is carbon, so this is alpha, there is no hydrogen over here. Don't say this is alpha hydrogen atom. This is not the alpha hydrogen atom. Alpha hydrogen atom is the one which is attached to alpha carbon atom. So this is called as cross aldol condensation. The mechanism and everything will remain same, absolutely same. This compound in presence of a base forms an adduct, first addition product, which is an aldol because it has got an ketonic group and an hydroxy group. Then in neighboring we have got hydrogen atom and oxygen atom. In presence of a base, it undergoes dehydration and we form an alpha beta. This is alpha, this is beta, unsaturated. In this case it is ketone. Alpha beta unsaturated ketone. So mechanism and all that remains the same. Just I'll explain to you. See here, first step, in the base this hydrogen goes away, so bond will shift over here, this will enolize. So we have got an enolate with double bond CH2. See here, we will get a double bond CH2. This enolate will act as a nucleophile and it will attack the benzaldehyde. So what we'll get is this bond will go away and form this to this bond, and this will form another enolate. This compound will abstract hydrogen from the base, which has become now conjugate acid now, and will have here OH. So this is your aldol. This is your aldol. Next step is dehydration, which is again very simple. Look here, we are repeating it. Base will abstract this hydrogen, bond will shift over here, so you will have a double bond over here, and this OH will be expelled, taken by the H of the conjugate acid and form a water molecule. So we'll have this compound. Okay. We'll start with the mechanism of the cross aldol condensation. Mechanism is same as the main aldol condensation, absolutely same. First step is the formation of aldol, second step is the dehydration. So see, in the first step acetophenone is there, we have a base, active hydrogen atom, removes hydrogen atom, bond shifts, forms enolate here. This enolate, which acts as a nucleophile, then attacks the electrophile, the benzaldehyde over here. The bond is formed, CC bond is formed, and another enolate is formed. This enolate then abstracts a proton from BH+, because our base has now changed into conjugate acid. So that attracts the H+, and we get an aldol over here, OH. Once the aldol is formed, then the next step is again very simple, that is dehydration, which we have done earlier. Here also I'll explain. In presence of a base, This H plus goes away, bond shifts over here, double bond is formed, and OH is expelled as water molecule, and you have got this unsaturated ketone. This is alpha carbon atom, this is beta, so it is alpha beta unsaturated ketone, and mechanism is complete for this one.